Large language models, or LLMs, have become incredibly advanced at generating and understanding text, but a key question is how well they handle complex narratives like stories. This research paper, titled Finding Flawed Fictions, Evaluating Complex Reasoning in Language Models via Plot Hole Detection, explores that by using plot holes as a way to test deeper reasoning skills. Stories are a core part of human life, helping us make sense of the world through characters, events, and their interactions. When we read or watch a story, we don't just follow the plot. We use skills like tracking details, understanding social dynamics, and spotting inconsistencies. These are things like plot holes, which are errors in a story that break its internal logic, such as a character having an injury in one scene and then in another without explanation. The researchers argue that existing benchmarks for LLMs, like those testing general knowledge or simple comprehension, don't fully capture these nuanced abilities. For instance, benchmarks might check if a model knows facts or follows basic logic, but they often skip over the pragmatic and social reasoning needed for stories. So, this paper proposes plot hole detection as a new proxy to evaluate how well LLMs truly understand and reason with language. To do this, the team introduced a tool called FlawedFictionsMaker, an algorithm designed to deliberately create plot holes in existing human-written stories. This allows for controlled experiments that are high quality and free from common issues like data contamination, where models might have seen the test data before. Let me break down how FlawedFictionsMaker works. It starts with a plot hole-free story, like a classic Sherlock Holmes tale. The algorithm first partitions the story into 3 acts, similar to how stories are structured in literature. For example, it might divide the story into an introduction, a middle conflict, and a resolution. Next, it extracts key facts from the story. In the Sherlock Holmes example, a fact might be that Dr. Watson has a war wound on his left arm. Then, the algorithm selects one of these facts and creates a counterfactual version, a made-up alternative that contradicts the original. So, instead of the wound being on the left arm, it changes it to the left knee. After that, it rebuilds the story by replacing the original fact with this new, contradicting one, but only in certain parts. This creates a plot hole. For instance, in the rebuilt story, early mentions might still refer to the arm, while later ones switch to the knee, leading to an inconsistency. Finally, the algorithm generates a new version of the story with this flaw and ensures it's coherent enough to test detection. To make sure the benchmark is reliable, the researchers added a human filtering step. Humans review the generated stories to confirm that the plot holes are clear, subtle enough to be challenging, and that the stories remain engaging and structurally sound. This results in a new dataset called Flawed Fictions, which consists of pairs of original stories and their flawed counterparts. Using this benchmark, the researchers tested several state-of-the-art LLMs on 2 main tasks. First, a binary task where the model has to say whether a plot hole exists in the story, and second, a localization task, where it must identify the exact error and point to the relevant parts of the text. The results were revealing. Even the best LLMs struggled significantly with plot hole detection. For example, their accuracy dropped as stories got longer, probably because longer narratives require maintaining more context and tracking more details over time. No matter how much reasoning effort the models were allowed, such as step-by-step thinking or multiple prompts, they still performed poorly, highlighting limitations in their ability to handle complex, multi-layered reasoning. The paper also examined how LLMs perform when they generate or summarize stories themselves. They found that LLM-generated summaries introduced plot holes at a rate more than 50% higher than in the original human-written stories. And for full story generation, the rate was over 100% higher, meaning the generated stories were even more inconsistent than the flawed ones created by the algorithm. This has important implications. It shows that while LLMs are great at producing fluent text, they often fail at maintaining narrative consistency, which relies on common sense reasoning, theory of mind, understanding characters' perspectives, and pragmatic understanding of how events unfold. For applications like writing books, creating movies, or even educational tools, this could lead to unreliable outputs that confuse or mislead users. Overall, this work underscores the need for better benchmarks that push LLMs to develop more human-like narrative skills. By focusing on plot holes, it provides a practical way to measure progress in language understanding, bridging the gap between surface-level tasks and deeper cognitive abilities. The researchers have made their code and dataset available on GitHub for others to build on, which could inspire future improvements in AI storytelling and reasoning.